next speaker is Grigorijs, and for those of you in the class, you obviously know him as being our technical assistant for the class. But if you haven't met him before, he's a PhD student here at CDU, started at the end of last year, and is working also with the Bushfires and Natural Hazards Cooperative Research Centre as part of the funding body for his study. So he's at the early stages of his PhD, and he's going to give us a bit more information about what he plans to do over the course of the next couple of years.
Okay, good day everybody. My today topics relates to the PhD research, what I hopefully will start soon from next month, because this month I have to finalize my proposal. And to start, it's easy from the basics and explain or remind what is a biomass and what we are going to talk about. And biomass, of course, can include as above ground or below ground, living dead, organic materials, and can be measured and relates metrics. In terms of use of remote sensing, we have to concentrate more on above ground biomass, and my research will be related to above ground biomass calculations and measurements using remote sensing data. Why is it important to estimate biomass? First of all, from classical point of view, it was necessary to perform a forest inventory. For example, estimate timber volume, because the timber production, the output from the forest. And from modern point of view, it's most or sometimes interesting how dynamically change the forest and what kind of conservation necessary for any type of necessary tasks. Of course, biomass, it's interesting from point of view as an energy and bioenergy sources. And last decade, first of all, the most accurate data what I'm going to use is a laser scanning. And laser scanning, it's a point cloud itself. It means we can describe the laser scanning data by density of the points. In my case, for instance, using Litchfield 2013, it's about 30 points per square meters. When we talk about the optical sensors, we have to keep in mind the optical resolution. It's mean pixel size. In world view, the highest resolution is 0.5 meter. And matching technique which used to extract 3D information from stereo, from optical sensors, the highest relates to the pixel size. It means if world view stereo imagery has 0.5 pixels, it means for each pixel it's possible at least to extract the height information. It means using world view to summarize, it's only 4 points per square meter. If translate the pixels to points, the highest resolution, but laser can give a 30, 40, 50, but in my research it will be not higher than 30, but not lower definitely than 10, because I suppose maybe second laser scanning missions will be necessary to perform, to finalize research and to do it in optimal way. Sorry for my long answer. We can say it can be critical component for tracking carbon and greenhouse gas cycling. My PhD thesis also relates to the forest fire management, because I have to find how fires influencing on the structure of the forest, structure of the trees. Therefore, biomass is necessary for fire management. Exist basically three major approaches to estimate biomass. First of all, classical is destructive, when we simply cut the tree, do weighting, which is not so sufficient and not so modern. We cannot cut all the trees in around us. Therefore, classically, traditionally, it was non-destructive estimates of using allometric equations, and the modern approaches relates to remote sensing. And allometry, which assumes a relationship exists between different type elements of the trees, elements of the forest, is the key of creating models, regressions, to perform the calculate the biomass. And allometry is again the basic assumption which can be used remote sensing in terms of estimation of biomass. Classically, again, or not classically, and generally, let's say, in case we need to measure biomass, what kind of tree metrics we need to use? First of all, we have to know height of the trees. If we are talking about the individual single tree approach, we need to know diameter of the breast, height of a tree, and tree species, which is basically relates to wood density. And second one is the area-based approach, which based on a statistical canopy height distributions around the plot. And again, it can include, to perform the measurements, we can use a different metrics. For example, at least we have to know the tree species. And for instance, we can use a tree basal area and then upscale it to all other plot. And again, for instance, using a basal area, it's connected to canopy height, crown area, and different other geometric 3D elements of the canopies. In terms of remote sensing, first of all, of course, biomass cannot be directly measured by any remote sensing sensors. We need to use some kind of indicator, and the major indicator can be canopy, if we're talking about the area, about the plot, or tree, if we're talking about the individual single tree heights. And again, using allometry correlations, allometry basic principles, establishing the association, correlation between tree heights and, for instance, wood volume, we can perform the estimation of biomass. For that, one of the major products, let's say, of the remote sensing can be canopy height models, which is results of deduction heights from the surface and corresponding terrain models. Most accurate height estimation, which we need to perform the biomass estimation, is use an active sensor, which is called a laser scanner, or LiDAR systems. And mostly of you, of course, know the basic principle of LiDAR, laser scanning, but just remind you what it's measure distance between the sensor itself. The position of the sensor is known by using combination of GPS, EMU, and knowing speed of light, time of traveling of the energy pulse. We can we can precisely calculate the position of the target. Some examples from the 2013 Lichfield laser scanning air mission. Point clouds, classical point cloud. If somebody doesn't know how it looks, you can see it. In isometric view, we can distinguish vegetation, tree structures, road, ditch, and so on. Another visualization of a laser scanning is intensity. The higher reflection of the material, the brighter it's represented. For instance, we can see on white stripes on a road. Basically, I can say this is a true orthophoto, black and white, and can be really useful. And for this part, we can see the elevation model, surface model, extracted terrain. We can see the biggest advantage of the laser scanning. It can penetrate the canopy. We see the ditch above the canopy. It can be seen from the looking on a surface model and a canopy height model. This is again difference between digital surface and digital terrain models. To finalize, laser scanning by extracting the tree heights give us opportunity to measure directly, basically indirectly, most of attributes relates to a tree, individual tree, single trees, or it can be relates to the canopy. And beside using a laser scanning, we need to think about the alternative, because the laser scanning, despite this is the most accurate method approach, it's one of the most expensive. Therefore, another alternative, another possibility to extract 3D information of the structure of the trees or the forest, let's say canopy height models, it can be used as stereo imagery. In my research, I will concentrate on worldview 2 using stereo imagery, which is a half of a meter resolution. Unfortunately, I haven't yet examples of savannas of Australia. Therefore, I'm playing now with some kind of demo data related to China. And I hope this result can be promising and the research can be successful despite some kind of limitation. For instance, single tree basically cannot be extracted from such kind of data. It's underestimation of the height of the trees and combination of merging of the trees which is close to each other. Of course, exist other methods of sensors like active radars, but my research will be more concentrated on laser scanning and stereo imagery of satellite. Basically, it will be worldview, which is a highest resolution satellite providing stereo imagery. And to finalize my short presentation, summary of the advantages and disadvantages using laser scanning, active sensors and passive sensors. And we can see what the most advantage of laser scanning is, of course, it's most accurate, most detailed, 3D special information relates to the objects, in my case in the forest, in the detail of the trees. But due to high cost, we have to look on the alternatives. And it's most important because to perform any task, we have to keep in mind the scales, the final product's map, how it relates to our task, how it can cover the area of our task. Basically, we keep in mind the classical map scale or modern resolution of the final products. Therefore, sometimes, despite on the fact what we have, we can use accurate sensors, we have to move to lower resolution imagery, lower resolution remote sensing to fulfill our task. And from practical point of view, it's most complicated task to find the compromise, the balance between the accuracy and budget expenses. It's all the fighting and time when to fulfill the task. And it's most important. And to finalize last words, it's one of my aim and task objective of research to build the bridge from the low resolution remote sensing data already exists, for instance, MODIS, and which allow us to perform the monitoring, for instance, of fires in North Territory, and with fine scale resolution remote sensing data. Thank you.